Hi everyone, we're going to finish up 5.3 by using some notation that we haven't seen in a while. Let's solve this equation. 3 sine of x minus 1 equals 0, and we want to find all real solutions. We're solving this on R. Well, this is a linear form in sine of x. We can isolate sine of x itself. Add 1 to both sides, divide by 3, not a problem. To isolate sine of x, add 1 to both sides, divide by 3, and we get sine of x equals 1/3. Now you agree, 1/3 is a legitimate sine value. It's between -1 and 1. So the solution set will not be the empty set. We will get real solutions. And in what quadrants will the solutions be in? In what two quadrants will sine of x be positive in value? Think y or vertical coordinate on the unit circle. Well, we're going to have solutions in quadrant 1 and in quadrant 2. But let's say I want to have exact names for these solutions. I don't just want decimal approximations. Or even if I wanted approximations, how could I figure these things out on my calculator? Well, it might help to have a reference angle. And the reference angle will be a solution. What is the acute angle in quadrant 1 where the y-coordinate here, the sine value, is 1/3? I need to draw the circle a bit better. There we go. All right, so what is this angle? What is this acute angle whose sine value is 1/3? What can we name it? The reference angle here, the acute angle. X equals what? The what of 1/3. The what of 1/3. Remember? Arc sine or inverse sine. More cleanly, over here. The best representative for this point here in quadrant 1 is the reference angle, the acute angle, arc sine of 1/3. His brother over here, what's the best representative for this brother point over here in quadrant 2? Well, pi minus the reference angle. These guys have the same reference angle. Okay, here's arc sine of 1/3. Okay, is the same reference angle, arc sine of 1/3 in blue here, So to get this angle over here, we do pi radians for half revolution. Pi radians for half a revolution, and then we backtrack. We go clockwise by the reference angle, which is this acute angle. Pi minus arc sine of 1/3. And since, okay, so now these are the two solutions between 0 and 2 pi, by the way. If we just wanted the two solutions between 0 and 2 pi, then it would just be these two guys over here. This and this. But if we want all real solutions, we also have to do our plus 2 pi n jazz to get all the coterminal twins. So our solution set can be written like this or like this. And there are other ways of writing it. The set of all x values in the reals such that x is of the form arc sine of 1/3 or inverse sine of 1/3, same thing, plus 2 pi n because we want all the coterminal twins where n is integer, or x is of the form pi minus arc sine of 1/3, or x equals pi minus inverse sine of 1/3 plus 2 pi n. We want all the coterminal twins where n is integer. This inverse trig notation, or we could write arc sine, arc cosine, arc tangent. We needed that because 1/3, although it was a legitimate sine value, it was not a special sine value. Okay, so we couldn't get a reference angle like pi over 3 or pi over 5 or something like that. The best we could do for description was the inverse sine or arc sine of 1/3 for our reference angle. And you could round that off using a calculator if we want rounded off approximations. Part G, using inverse functions and the corresponding notation. When you're finding reference angles, you're kind of applying the idea of inverse functions anyway, but sometimes we actually need the inverse sine or arc sine notation especially if we're on a part of an exam where we're not allowed to use our calculators, if we have to give exact expressions for our solutions. Bear in mind, if you're allowed to use calculators, you may have to round these off anyway. Next up, 19 more identities you have to know.